Hello and welcome. Sorry for the technical issues, but today we are talking about basically looking at animal models in the study of multiple sclerosis and really how helpful are they. We've had decades of MS research and we're not getting any closer to the cure. I was diagnosed with multiple sclerosis over 34 years ago, and again, we still are no closer to finding a cure. We still don't know what causes MS. So are these animal studies really helpful in helping us to find a cure for multiple sclerosis? So maybe you've wondered at some point, like, how is it possible that researchers can give mice and rats a condition that's really similar to multiple sclerosis so they can study MS when they don't know what causes multiple sclerosis? And we're going to talk about that because I really believe that this type of research is not just hindering us, but preventing us from finding a cure for multiple sclerosis. If we haven't met, my name is Pam Bartha, and I'm the author of Become a Wellness Champion and the founder of Live Disease Free. And my goal is to help bring the truth out. And if you enjoy watching my videos, if you enjoy watching the trainings, I do a lot of research. Please share and like and subscribe to help me to get the word out. This is the only way things are going to change. So today I'm going to share with you just a few different ways that these studies are done with mice where they're trying to research MS. And honestly, when we're looking at animal studies, these studies are really to try to find new drugs, to test new drugs. So they're not really looking for a cure for multiple sclerosis. They're not looking at the cause. They're not looking for the cause of MS, and that's a really important thing. So before we start, I just wanted to mention again that there's 4 types of multiple sclerosis. We know that MS is an inflammatory disease. We know that our immune system is fighting. Inflammation is the war zone between our immune system and the enemy. And the enemy in multiple sclerosis is not known, but we know that our immune system, it is designed to treat different types of infections, different types of parasites. And if you follow my work, I share a lot about that. So I just want to make sure you guys can hear me. It's working now. Yay. Awesome. So please just, if there's any questions about the sound, sounds like everything's great, type your question in the question box. If I have time, I'm going to come to your questions at the end. So we know that it's an inflammatory disease. We know that our immune system is fighting something, some mysterious thing. I know that in the scientific community, they're calling it an autoimmune disease, but honestly, there is not a lot of evidence for that, especially when you look at the animal studies, because you'll see that it doesn't indicate that it's an autoimmune disease. And I think a big part of the reason why we're not getting anywhere with finding a cure is because there's a lot of money in the MS drugs, and we don't understand the language of science. Like all these big words, we just basically leave our healthcare up to the experts. And what we're finding is that we're not getting anywhere, and we're suffering terribly, and we're dying early. We're ending up in extended care facilities, and we're not getting to the root cause. And we do know the root cause is infection. So we know the immune system fights infection. We know we're dealing with a parasitic infestation. If you haven't looked at my work, make sure we've got playlists on YouTube. We are moving on to Rumble just because there's a lot more free speech there. But just know that there is hope for you. There is an answer. There really is a cause. But why do we keep focusing on these animal studies? So the 4 types of MS is a clinically isolated syndrome where sometimes people will get one neurological attack, which are symptoms similar to multiple sclerosis. And I did a live event about, a week or 2 ago talking about are antibiotics helpful for multiple sclerosis. I'm not an advocate for antibiotics for treating MS, but there is some evidence that if people are having that one isolated flare, they're catching it really early, that there can be some benefits to giving them specific antibiotics. So that is just more evidence that MS is an infectious disease. But again, we want a cure. We don't want just some slight improvements. Then there's also relapsing remitting MS, where we have an attack and then we have a remission where we basically usually recover, and then we get another attack. And it can go, sometimes people can go for 5 or 10 years without an attack. Sometimes people have it more often. And I really believe it is our environment that causes us to have more frequent or less frequent attacks. Then there is secondary progressive. So most relapsing remitting MS turns into progressive MS in time, like well over 80%. And then there is primary progressive multiple sclerosis. And this is where we have a continual decline in our health. We don't get any breaks. We just become more and more disabled continuously. And I know that there's a couple of other subgroups of MS, but those are really the main ones: relapsing remitting and secondary progressive and primary progressive. So again, these animal model studies are really done for the benefit of pharmaceutical companies. So the pharmaceutical companies, they fund research using these animal models to test different, these are clinical trials. I mean, clinical trials are probably more with the humans, but to start testing their drugs. But when you look at this, it's so far off from what MS really is. What is the benefit of this? That's what we're going to talk about today. So they share in this one particular study that, well, it's true that animals, when you use animals, that they are an easy way to get access to material from the central nervous system, right? Compared to getting it from humans. But they also say that autopsies are rarely done with MS patients. And my question is why? Why are we not looking at MS patients who have the MS to see what is causing the inflammation in their central nervous system? For example, if somebody is having a spinal tap, the lumbar puncture, why are we not spending more time analyzing the spinal fluid? Why are doctors not allowed to have microscopes in their lab, in their offices, or why are they not allowed to use microscopes? So the diagnostic, the lab work is very, very controlled in our healthcare system right now. All of our spinal fluid and our blood, et cetera, urine goes to specific labs, and they can only do specific types of testing on them. So there's not a lot of investigative work. I should say too, there is some research that is taking place that is helpful. So for example, the University of Alberta, University of Calgary in Alberta, Canada, they are actually looking at the types of microbes, how different they are in MS patients versus healthy people. And that is helpful research, where you're actually looking at the patient, you're looking at the person who has MS, and you're trying to figure out what is causing these neurological symptoms. And so there's a lot of research going on in the whole dysbiosis, which I talk about, how the microbes that live in the body of an MS patient are very different than a healthy person. And I've done lots of research on that. And again, it's caused by parasitic infestation. So my question is, why are we not allowing the researchers, and why is there not as much funding going into that area? Because there's no money in it. Because literally, if we were to treat parasites, it would be simple treatment with old drugs that are not patentable, and people would get well, and the market, the multi-million or billion-dollar market, would no longer be needed. So again, several researchers have really questioned whether these animal models, whether they're a good representation of what happens in patients that have multiple sclerosis. And the way that these animals are made to have a condition that looks similar to multiple sclerosis is they're injecting, they call it immunizing, these animals. And my heart goes out. I love animals. And mice, I'm from a country and mice are kind of a pain, but they're cute and they're animals and they all serve a purpose. And to me, it's cruelty to animals if we are doing research and we're genetically modifying them, we're injecting them with all kinds of horrible things when we're really not focused on finding a cure. We're really trying to find the best disease-modifying drug, meaning the researchers, the pharmaceutical companies are trying to find the best treatment that they can prescribe for the rest of your life, okay? That they're not looking for a cure, they're looking to allow you to live with the disease, to maintain the disease. So there are certain things that they're concerned about, that the researchers that say that, this is not really a good model for MS patients using these lab rats. Again, number one, it's the way that the disease is initiated. For example, with the animals, they are injecting them, and we'll talk about what they're injecting them with, versus multiple sclerosis. It's something that happens years before, right? And then we get a diagnosis years later. The time frame of the first symptoms is very different between humans and mice. Again, it's artificially induced in the animals, whereas with humans, we may be working or having MS develop in us for years. And again, that's the parasitic infestation. So we have parasites, but there comes a point when the parasites become too populated and our immune system is no longer able to deal with things properly. And we have immune dysfunction, we have too much inflammation, etc. So another thing is that drug testing starts very early in the animal model. So they will immunize the animals, and then they'll start to test drugs on them right away. Where with humans that have multiple sclerosis, we have kind of warning signs for years before. It takes a while to get a diagnosis, and then they start to use therapies that they would like to use for us. Most of the experimental studies that they're doing, they're using these inbred and genetically modified mice that are all genetically the same. And often these mice have several genetic abnormalities that are virtually impossible to find in humans. So we're not mice, that's one thing. Our immune system is very different. There are profound differences in our immune system and the immune systems of mice, but also just the fact that they're not even taking healthy mice. They're taking mice that are like completely genetically modified, and they're susceptible to different diseases. They're not healthy mice, and they're injecting them with all kinds of disgusting poisons. And we'll talk about, we'll kind of at the end, we'll wrap this up and really look at like, how is it possible that we could even be using this to study MS? Because it's so different. Or, I mean, for them, they don't know what MS is caused by, but it is, we'll talk about that. Anyhow, so basically, again, these animal studies are really for drug discovery. And the drugs they're looking for are not a cure. They are called disease-modifying drugs, maintenance drugs you take for the rest of your life. So there are three common types, there's extra, but we're going to just talk about three common types of animal models for studying multiple sclerosis. And I'm going to keep it as simple as possible. I will write out the longer terms in my blog post so that for those of you that are science buffs, you can look at that later. But the key is right now is I want to keep it really simple so I don't lose you. So number one, a common animal model you may have heard is EAE. So we'll just remember EAE is one type of animal model of mice, and they're really looking at kind of like the immune response, and they call it autoimmunity. They're saying that our immune system is attacking itself for no reason. I totally disagree with that, because if that was the case, how could I recover? How can other wellness champions recover? The second type of animal model is where they are basically giving mice a specific virus. They're actually looking at maybe not the immune response, but they're looking at the demyelination kind of the disease, or of disease, because we know this is not MS. So they're taking these transgenic, genetically modified mice, and they're injecting them with a virus. And it is interesting, it is a type of coronavirus. I think it's a pi coronavirus. And the third one is where they're actually immunizing these mice with toxins to cause demyelination. So we'll talk, I don't want to get ahead of myself. So again, they have one type, which is an EAE type, which is kind of looking at the autoimmune, what they call autoimmune of multiple sclerosis, and then two others where they're kind of studying demyelination, one using a virus and another just using a toxin, a really strong toxin. And there is this solution that they do mix in, and it's really important to know this. So there is an adjuvant that they add to it to actually make a stronger immune response. And basically they're using a bacteria that causes tuberculosis. So it's a killed bacteria that causes a strong immune response, and that often is used in helping, because what they're trying to do with these poor mice is they're trying to get the immune system to fight in the central nervous system. So they do this again through adding viruses, through adding different toxins, and also this adjuvant which contains dead bacteria, or its animals are immunized with killed bacteria that causes tuberculosis to create an intense sensitization that lasts for a long time because they want to study it. So they will also use fragments from the central nervous system. So they will use a myelin basic protein, we'll call it an MBP, just a myelin protein. I'm trying to keep it simple, and a proteolipid protein, PLP, so you'll hear me say MBP and a PLP, and also a myelin oligodendrocyte, glycoprotein, so it's a MOG, M-O-G. So the oligodendrocytes, those are cells that are involved in, I just wanted to double check here, but making the myelin. And so what they're doing in these studies is they're taking fragments of myelin and fragments of these cells, and they are immunizing, injecting the animals with it. And we have to understand that our immune system are our soldiers. And whenever there is something like a lot of cell damage, or there are toxins present, or bacteria present, or viruses present, they're going to go to work, right? We can't, and that's not called autoimmunity. That's just called they're doing their job. And I wanted to just mention this one type, so you have an example of like how these poor mice are treated. So SJL/J mouse, this specific mouse, it's genetically modified. It displays a very high incidence of reticulum cell carcinoma resembling Hodgkin's disease in approximately 1 year of age. So this is like, it has a higher incidence of getting this specific cancer that will affect cells in the spleen, the lymph nodes, and also microglial cells. And those are like immune cells in our central nervous system. So I know this is where I'm trying to keep it simple. So these mice are bred, and they're really susceptible to a specific type of cancer. And they also are characterized by extreme aggression in males and susceptibility to EAE. So remember, that's the type of study they want to look at, the autoimmune part of MS, which I don't believe in it. It's basically the immune response, right? So that's just one type of mouse. And there are other types of mice. So I'm not going to go into all the different types of mice, but it just kind of gives you an idea of, these are not healthy animals. These are sick animals. They're bred. They're more susceptible to disease. They have all kinds of genetic alterations. And that's not a human. That is not a human. So how in the world are we using, like, number one, a mouse and a human are totally different. Number two, you make these animals like not normal. Yes, mice are mammals and we're mammals, but we're still very different. And then you genetically modify them so that they're like susceptible to cancer and they're aggressive and who knows whatever else. They have a lot of genetic abnormalities that you don't find in humans. So this is a bit of a stretch for sure. There's a nice table in this study where they kind of simplify down just a few of these animal models. So when they want to study relapsing, remitting multiple sclerosis, so they use the EAE version and they use the mouse. So they're using that SJL/L mice for this. So they're injecting or immunizing this specific mouse with a fragment from the central nervous system. I'm going to keep it really simple. And so they're injecting that into the mouse. And what they want to study is neuroinflammation and immune system activation. So you know, it's okay to possibly like understand how our immune system works in our central nervous system, but to use these animals then to try to see if a certain drug will work for MS for humans is a really big stretch. So when they are taking these poor EAE animals or the SJL/J mice, and they're immunizing them with the fragments from the central nervous system. Actually, it's myelin fragments here. And they're looking at, neuroinflammation. Neuro means the nervous system. Inflammation means your immune system is fighting. And so they're looking at our B cells, they're looking at T cells, they're looking at monocytes, they're looking at macro. So they're looking at all kinds of different immune cells and how they're reacting to this myelin protein that they've injected into this sick animal that's been genetically modified. And why they're using this type of approach with using these fragments of like the myelin, for example, is that they want to study relapsing remitting multiple sclerosis. And the big stretch is that would be relevant to humans. I don't know if you see a really big gap here, but I sure do. So the translational value, what's the value of doing this study? It is trying to understand relapsing remitting multiple sclerosis, studying relapse rate. The relapse rate in a genetically modified mouse that they're injecting myelin protein fragments into them, causing an immune response, that has nothing to do with the relapse rate of a person, a human being, their environment. Like there's just no similarities, right? And even from person to person, the relapse rate is very different. Some people can go 5 or 10 years without a relapse, and other people, they have relapses more often. And that, I believe, is really caused by our environment. How much stress are we under? Are we sleeping? Are we eating a lot of food that will feed the parasites? All of these different factors. Are we living in a moldy environment? Do we have a lot of wireless radiation? So what are the things that are really hard on our immune system when we're already dealing with a parasitic infestation? That is what causes our relapse rates, not giving a genetically modified mouse in the lab, giving them, injecting fragments of myelin into them and having the immune system react to that. That is like, we'll talk, I was trying to think of a good analogy, and I'll try to come up. If you guys can think of an analogy, let me know. Like type it in the question box. It's such a big stretch. It's kind of like, if people are breaking their leg, and so the researcher's like, okay, let's just research like what happens when somebody's leg is broken, and how do the immune cells and how does the body heal itself? But that doesn't tell you what caused the person to break their leg, right? And that it's not helpful at all. Like it could be it could be somebody skiing, it could be somebody in a car accident, it could be completely different things. You don't know until you actually study what the cause of something is. All right, so number 2, this is chronic EAE in a different type of mouse, which is a C57BL6J mouse. And again, this is a genetically modified mouse. And here, what they're doing is they're giving this poor mouse, it is another myelin oligodendrocyte glycoprotein. So again, it's just giving them like little fragments of the central nervous system. So like damaged oligodendrocytes from your central nervous system. And those oligodendrocytes, I believe, are there to make myelin for the nerve cells. So, and we call it MOG, M-O-G. So I'll just call it MOG. That fragment is what's used. And in order to make sure the immune system like acts up enough, they also add the pertussis toxin, which is from whooping cough. It's an awful toxin. And they also add that adjuvant that I talked to you about before, where they are like really causing a strong immune reaction to this dead tuberculosis bacteria. So they're like priming the condition, like they're priming the immune response, because maybe the myelin protein didn't give a strong enough response to these cells. So again, now they're kind of probably, when you're talking about chronic, they're kind of thinking, well, let's look at progressive multiple sclerosis, right? So yes, they're looking at trying to study primary progressive, secondary progressive drugs for those conditions. Again, with a genetically modified mouse where they're injecting them with pertussis toxin with a concoction that is like causing super sensitization because it originally contained the tuberculosis, dead bacteria, and they've also added in myelin fragments. So they are studying neuroinflammation with this and immune system activation. Well, of course the immune system is going to be activated, but does that mean that's what's causing MS in us? Not even. You can't even bring that together. Like it's, and this has been going on for a long time, all these animal studies. All right, so again, the cells involved, different T cells, B cells, macrophages. They're looking at all these different immune cells, how they react to pertussis toxin, to this adjuvant they add, and also to the myelin fragments that they're adding into these poor genetically modified mice. Number 3, EAE in transgenic mice. So these are, again, adding the MOG, which is the myelin, but also there is called B cell heavy chain knockout. So I think it has to do with their affecting their B cells. Again, studying neuroinflammation, immune activation, looking at the different types of cells, how they're involved in all of this. And here they're studying immune cell activation and function to those particular allergens or enemies or toxins, right? It's not, it may have nothing to do with multiple sclerosis, but you can see that a pertussis toxin can cause neurological damage in the central nervous system, and that is from an infectious agent. So again, that gives us clues. We know that infection in the central nervous system can cause neurological damage, absolutely. But we also know that infection in the gut can also cause a lot of neurological symptoms. Number 4, this is the Thielmer's murine encephalomyelitis virus. We'll call it a TMEV, TMEV. So here they're giving the poor mice this PI coronavirus, and they're injecting them with this, and it's known to cause a lot of inflammation. They're studying nerve damage, and they're studying the inflammatory induced demyelination. So they're studying nerve damage and demyelination, looking at different cells involved, macrophage, so the immune cells that are in the central nervous system. Like when we inject these poisons into this virus into the central nervous system, like how are the immune cells in these mice reacting to that? Again, these are transgenic mice. They are not even normal mice. And the value of doing this is to study primary progressive multiple sclerosis, to study the brain, the brainstem, the spinal cord lesions, and to study new therapeutic approaches. And that's really the bottom line. And the 5th one is this cuprizone-induced MS. And so this is where they're feeding these C57BL6 mice. So that's not the first type, but that's the second type of mouse. And they could have many other types of mice. And they're giving them this cuprizone, 2% for 6 weeks. And it is a copper chelating agent that is administered to the rats. And it is used to induce the death of the oligodendroglial cells and glial cell activation. So of course, if the oligodendrocytes, those cells that help produce myelin, if those cells are dying, of course our immune cells are going to be activated. So they're like, oh, well, if we give them this poison that kills off the myelin producing cells, and let's just observe how the glial cells, how their immune cells respond to that, and how demyelination through mitochondrial dysfunction is occurring. So here they're trying to study demyelination and remyelination processes. They're also looking at cells involved, the oligodendrocytes, the astrocytes, and the microglia. And why are they doing this? Therapeutic trials, drug trials, right? The last one I wanted to share, so I'm trying to keep this really simple, but basically there is a substance that is injected into them that is very toxic to the myelin, to this specific mice. And they're studying, again, demyelation and remyelation processes. It's all the same, looking at the cells involved, which are oligodendrocytes and astrocytes, and also microglia, again, for therapeutic trials, for studying drugs, basically. All right, so lots of problems here. I hope you can see this. To me, it's just insanity. I don't know. I know I study a lot of this stuff, but I hope I've showed you just enough that you can see what a stretch this is. And this is why we're not finding a cure for multiple sclerosis. It's not that it is so hard to find a cure. It's that we're not even looking in the right place for a cure. We're not. We are literally studying these. And of course, these pharmaceutical companies, they want to practice their drugs on something. But is that even remotely close to what multiple sclerosis is? I would argue there's no way that they can prove that. So some of the limitations they talk about is that these EAE model of multiple sclerosis, they involve very few information about, like, you're not getting a lot of information about the progression of multiple sclerosis. Also, the use of mice, the C57BL/6 mice, they don't allow for the study of relapse rates because, like, this is totally artificial. This has nothing to do with human relapse rates in humans. Number 3, remyelination is difficult to be studied in EAE. Lesions occur just in different areas regarding the timing and localization, and furthermore, looking to see here, they haven't really done a lot of studying on myelin damage in EAE tissues. It has not been performed thus far. Mechanistic insights into myelin damage in EAE tissue has not been performed so far. Studies aiming at evaluating the potential benefits of new drugs for neural growth, so the growth of nerves and the survival factors, has been unsatisfactory, and most of the effects are off target, making any results very difficult to interpret. Again, very difficult to interpret. EAE is mainly a disease affecting the spinal cord white matter, whereas multiple sclerosis is mainly a brain disease with demyelination of the central and cerebral cortex. So, like, totally different areas. So the EAE, the damage is in the white matter, is completely different areas for MS and EAE. And so unfortunately, there's only a few studies that analyze the involvement of the cortex in EAE. And they also don't, in the EAE studies, they don't extensively analyze the role of B cells in the process of the disease. Again, there's something in our immune system, and our immune cells are trying to defend us. Just like if they injected these poor mice with pertussis toxin, with these different fragments from the central nervous system, viruses, when they put all this awful stuff in their central nervous system, their immune system is going to react. That's not autoimmunity, that's just the job of the immune system. And so the B cells, it's not helping us to understand. And again, the reason they want to pin it on B cells and T cells is because specific disease-modifying drugs, the MS drugs, they target the B cells and they target the T cells. They make us sicker, they make us weaker. They're not treating the parasitic infestation that's causing the inflammation. So although the damage to the nerve is observed in multiple sclerosis and its animal model, so yes, there's damage to nerves in both multiple sclerosis and in EAE mouse models, but it's believed that the damage to the nerves occurs secondly to the severe inflammation, like the demyelination that we have, where lesions develop from the outside, the myelin, to the inside, to the axon in humans. And with this viral infection that they gave those poor mice, the axon damage comes before the demyelination. So it's exactly the opposite of multiple sclerosis, of what happens in multiple sclerosis. And then also that TMEV model, so the virus model of trying to study multiple sclerosis, it is, so the TMEV model and the EAE display several important differences, such as a requirement for viral persistence, immune system activation, and neuropathogenic mechanism and clinical outcourses. So the negative aspects or the limitations of the TMEV, and I just want to make sure that that was the virus one, I'm pretty sure. Let me just look here. Yes, the pi coronavirus, where they gave those poor animals that virus. So the limitations of that one is that this TMEV, so that type of animal model where they're giving them that virus, it can induce inflammatory demyelinating disease only in mice. So what is the point? They're giving these poor mice this virus, and it can only cause demyelination in mice, not in humans. So it's not even going to be a cause for multiple sclerosis. They're just trying to study when we put poisons, when we put viruses in these poor mice, like are we getting, we're immunizing them, which sounds really nice. Are we getting an immune response, like the central nervous system? Is it acting up? And how does it act up when you poison it? Of course it's going to. And the disease part, or the pathogenesis, which is like the disease of the TMEV, so that's the virus-induced condition, induced demyelination in part differs from that in humans, where persistent viral infections of the central nervous system have not been demonstrated in humans. So all in all, you can see, and I've just literally scratched the surface, and I've tried to make it as simple as possible, but you can see that these animal studies are solely for the benefit of drug research. And the drug research that's being done is solely for disease-modifying drugs. These drugs that we're supposed to take for the rest of our lives, like the newer drugs, for example, I'm not going to talk about names specifically, but we're supposed to take these drugs, we're supposed to suppress our immune system for the rest of our life. So they're literally making these animals sick, causing immune response, and they're like, well, which drug can shut down the immune system? The B cells, the T cells, the microglia, the glial cells, whatever. And then we could just give that to MS patients and it can shut down their immune cells, and then maybe they're going to feel a little better, but they're going to have to keep taking it because those parasites are still there that are causing the inflammation. And so we can have revenue for years and years and years from each MS patient. And this is true for all chronic disease, whether it's any type of autoimmune disease, all of these maintenance pharmaceuticals. And I'm not against pharmaceuticals. There's a time and a place, crisis intervention, save your life, get you out of the danger zone. But for chronic disease, they literally are robbing us of our life. And I hope that you will help me to get this information out. Again, it's very confusing. I am going to post my video, and I'm going to post the written part of this so that you can kind of go over it and digest it a little bit. Please share this with different groups, MS groups, if you have an integrated practitioner that's interested in this kind of information, just keep sharing all this information. You guys are the foot soldiers. You guys are the ones that are going to help us bring change. I can't do this by myself. We have to get the word out. And it's really cool because I hear, different practitioners in different countries, they know of me, they know of the work that we're doing. Some of them are super, super excited. And so we have to bring this to the people. We're living in very different times right now, and there's a lot of things down the pipe that are going to really, if they come true, they're going to make it much more difficult for us to get this information out. So we have maybe a year to a year and a half. Hopefully those things are not going to come through, but we do have limited time to get this out. And that's why I'm going to be, this next year, I'm going to be really pushing harder to get this information out. So hello, you guys can hear me well. See if you guys have any quick questions. I know I went on a little longer this time than normal. How long do you recommend following the diet before you start treating the infections? Janet is wondering. So number one, if you're noticing a lot of symptom improvements by following the Live Disease-Free diet, that can happen in as little as 2 weeks. So we do that first, but again, it's not just like following the guidelines, and we do have them available on our website, but it's also, am I noticing symptom improvements? We have to get the carbs low enough so the parasites are less active, there's less inflammation, and we start to have major symptoms. We have some students that are not really treating and they're noticing huge differences in balance, less spasticity, of course, bladder function improves. So like all these things, sleeping better, having a better mood, brain fog clearing. So all of those things you want to be having, the more symptom improvement you have with the diet, the easier it will be to treat, the more you'll tolerate the treatments, and the quicker you'll be able to treat and recover. So the diet is number one, but it can literally take, if you follow it, if you get your carbs low enough where you're having a lot of symptom improvements, it could take a couple, 3 weeks. Number two is to support the body. So this is where we have a checklist for healing. It's literally, looking at our blood work, supporting our physiology, making sure we're having daily bowel movements, we're sleeping well at night, and making sure that we're decreasing certain toxins in our environment. We have a checklist that you go through. So by the time you're ready to treat, you're already feeling a lot better. And then we start the treatment phase, and we're using a combination of an oxidizing agent, which I can't talk about here. You can find that on Rumble. It's called Oxygen Therapies for Treating Parasites. We're using different parasite drugs and that we test well for. And we're using antimicrobial herbs, and we're using them safely, and we're using them effectively, and we're making sure that we check our blood work. So the students are working in a responsible, safe way, using practitioners, and what they're finding is that using the combination of all of this, they're recovering much more quickly than before they use the parasite drug treatments, and they're having more recovery. Like people that haven't walked for many years, I could never promise that they'd be able to walk again. After maybe 12 treatment cycles, they're starting to take steps. It's crazy. So it is such an exciting time. There's so much more recovery that we can have than that we ever thought possible. The sooner we treat, it's still going to be work, but the easier it is to treat. And there is so much research. If you're new to this, make sure to go onto our YouTube channel, look at the playlists about the infections, start to change your diet, start to feel better, and go onto Rumble. There's a little bit more sensitive material there. Go to our website, Live Disease-Free, get the guidelines for the diet, get all the information, build up your belief system, really understand. And when you're at that place, you're like, Pam, I know I have parasites. I know that's what's making me sick. And if you need a plan, if you need support, we can help you with the Live Disease-Free plan. You just simply click on the link that's beside this video, and you'll be able to watch my masterclass training. You'll be able to understand the steps that we take to recover from chronic disease, and you'll hear a bunch of wonderful success stories of students that have recovered. And this is what our health care for recovering from multiple sclerosis and other chronic diseases must be in the future. This is treating the root cause is the only way. There's no diet, there's no supplements that'll give you your life back. You have to treat the parasites. So watch my masterclass training when and if you're at a place where you want support, you want a plan, you want guidance, because a lot of people have a hard time finding even practitioners that will help them to treat. So David, a meat and protein diet makes us acidic? No, that's not true. So I know we've been told that, and there's a lot of false information out there, and it's really frustrating. So if you have a parasitic infestation and you're on a solely plant-based diet where you have no animal protein, it actually makes you feel worse because we're eating a lot of carbs. Even if you're not eating a lot of sugar, you're eating a lot of carbs. They break down to sugars in your blood, and that feeds the parasites. So we know that these parasites, as long as we don't eat huge amounts of meat, then eating moderate amounts of meat, eating enough healthy fat to maintain our weight, and then eating lots of low-carb vegetables, you'll feel like a different person. You really will. The acidity that we have is caused by the acids produced by the parasites. When you treat the parasites, you'll notice that your pH will go up significantly. There are people that are on carnivore diets, and I don't recommend that unless you really can't eat anything else. You're so sick, everything makes you sick. Then if you follow it properly, where you're eating a lot of fat and just moderate amounts of protein, it can work. But again, it's not treating the parasites that are causing your symptoms. So if it was that helpful to get rid of meat because it's acidic, then people on the paleo or on the carnivore diet, they would not do so well compared to a complete plant-sourced diet. So the plant-sourced diet is not good for our insulin levels. I think that we need a balance of things. But if you are really in balance, if you don't have gut issues, if you don't have chronic disease, you probably can follow a plant-sourced diet safely, making sure you get your vitamin B12 and getting enough amino acids, etc. But it's harder. It's definitely harder. You have to really be intentional. Hello, Maureen. Hi, Jennifer. Sorry that I was late. Technology sometimes. I don't know. So, Jennifer, may I ask, why is the medical field not testing tumors, masses for viruses like the Epstein-Barr virus, which is scientifically linked to cancers and autoimmune disease? That's a good question. And Jennifer, from the research that I've done, I really question whether viruses are the main cause, because we are recovering by treating parasites. I know that if we have a lot of different parasites and we're really out of balance, then viruses could be more active. But I've done a video on looking at the Epstein-Barr virus, the research that just came out at the beginning of 2022. It was a very weak study. And so when you really start to look at the research, you'll see that there's not a lot of evidence that show that these diseases are caused. But protists for sure can cause tumors. Worms, we know for sure, can cause tumors. And so as we treat the bigger parasites, a lot of times our immune system, if a virus is present, it will deal with the virus. And why they are not testing tumors for different types of parasites, because if that evidence got out, then they would have to stop using the current treatments for cancer, for multiple sclerosis, for all autoimmune disease. These are multi-billion-dollar industries, like the sickness industry. So there's no money. Like these parasite drugs are old, they're not patentable, they're safe. You use them for short periods of time to treat, and they treat cancer, they treat all kinds of diseases, epilepsy. Sometimes it's a worm in the brain where we have epilepsy. And cancer is linked to like different, I'm not going to say the names of them here, but different parasite drugs are very effective for treating cancer. And some doctors know this. And yet they're just like, well, I'm in the system. This is the way the system goes. So I'll just do my practice and I'll go home at night. And it's so wrong. It is so wrong. And some doctors really don't know. They have been taught, they have been conditioned for many, many years while they were learning that their parasites are not present in developed countries, which is not true. Parasites are all around us. They're part of life. And we deworm all of our animals, but we don't deworm ourselves. They are in our soil. They are on our produce. They are, if we eat in a restaurant, they could be on our food from if we're eating, something that's not cooked. They're on the shopping cart. They're everywhere. And it's not that we have to be paranoid, but what we want to do is we want to restore balance. We want to build back our natural defense, bring back the health-promoting microbes, and then just learn how to live with them for the rest of our life. And that means maybe once or twice a year treating parasites to prevent disease. So Jennifer, scientific research states that Epstein-Barr virus is the leading cause of MS. Watch my video that I did, and I believe it was in January 2022. You'll find it on YouTube and Facebook. And look at listen to my video, go over the study, and you'll be like, oh, it's pretty weak. Hi, Anthony. Hi, Monica. A couple more questions here. I know we haven't gone an hour because we started 15 minutes late. So Monica, how many grams of, do you recommend to take each day? And I think maybe you're saying chlorella. That's not spelt right, but chlorella. I don't want to say that here just because I don't want to give any kind of advice here on a public forum, but chlorella is, what you want to look for is cracked cell wall, and also if it's grown in a pool versus if it's grown in the ocean, it usually will contain less toxins. And depending on how old you are, whether you're pregnant or children, it's very, very safe to take, and you can take it 3 times a day. You can take multiple tablets, but again, look for cracked cell wall. And also, if it is grown in a pool versus the ocean, can be really helpful. So it's a superfood, and it helps to bind mycotoxins. It also helps to bind mercury and other toxins. So it's part of the detox, but you're not going to recover from chronic disease with taking chlorella alone. You've got to treat the parasites. So Jennifer, could it be possible that people having relapses because they don't know how to treat viruses like Epstein-Barr? You need to do a little research on that. You'll find that it's not the Epstein-Barr that's causing the MS. Could it be more active? The problem is with Epstein-Barr, it's present in over 90%. It could be like 95% of the general population has Epstein-Barr virus. So if almost 100% of the population has Epstein-Barr, then wouldn't we see a lot more people with multiple sclerosis? So that whole connection, as you dig in, you'll see that there's a lot missing. All right, hi Anthony, you have an MS doctor gave you think that it's making you worse anyway, it's not helping, for sure. The MS drugs are going to suppress your immune system. That's all that they do, is they suppress your soldiers that are there to fight the parasites that are making you sick. You need your immune system. You need your soldiers. You need to treat the parasites. And for Jennifer, like what I would encourage you to do is to look at the research, like go through our blog. We've got really good, there's a lot of videos on YouTube, but also on livediseasefree.com, you'll see a lot of our blog posts. They're very research oriented, but keeping it as simple as possible. Louise, is it too simplistic to suggest that researchers should inject mice with parasites? Well, that would be a better study. So for example, we know that when domestic animals have these filarial worms so this is known in science, we don't have to study it. When domestic animals, so dogs, horses, cattle, sheep, when they have these little small roundworms, filarial worms in their central nervous system, they have all the symptoms of multiple sclerosis. This has been known for over 100 years. The veterinarians have known that. And Dr. Alan McDonald looked at 10 people that died and they had MS, so their remains were in brain banks for research purposes. He found many, many of these worms in every single case of MS. He also found developing tapeworms. So you can imagine that these worms and tapeworms would cause a lot more damage than a virus. A virus is way smaller, and so that's really important to know. So there's a lot of research showing, like in animal studies, like how these parasites, how the roundworms affect animals, how the flukes affect animals. We don't even have to do a lot of studies, and you'll see all the symptoms that we have, like flukes causing tons of inflammation and edema and all kinds of symptoms, right? Different cramping and all kinds of things. So it's been intentionally withheld from us. It's been intentionally withheld, not maybe from your neurologist because they're just doing their job, but from the very top. It's been intentionally withheld from researchers, and so it's frustrating. All right, and Karen, you're so welcome. Poor mice, it is awful. It's not being a good steward, right? Okay, last question here. So you're taking the O infusion every 6 months at Stanford. Please be aware that that infusion is destroying your B cells. And so what is an adverse effect of destroying your B cells? Cancer. So there are women that have aggressive breast cancer, and you can have other types of cancers. Your B cells are necessary to defend you from infection. And if you're taking that, you're destroying your natural defense, which will make you not just, you'll have MS. You will still have MS. It's not going to stop the MS, because the MS is caused by parasites, not by any deficiency in your B cells. And then you aren't going to have the B cells, and then you are susceptible to cancer. So MS is bad enough. Cancer is terrible. So the information on the diet you'll find on our website. Does zapping help? Not enough if you're dealing with chronic disease. It's something you can do. I've been through all of that stuff. 34 years, we've tried almost everything. And I've got a couple of little zappers. I've used Dr. Hulda Clark's, the broad things. It's not enough. There's the Rife machine. Could be helpful for very, very small parasites if you're working with the right practitioner. But to recover from chronic disease, you've got to use the plan that we use. Otherwise, it depends what your goal is. How do you get rid of mold? You have to work with a mold remediation company. Your home is number one. And then number two is using specific binders that will bind mold, and then also treating. You may have it in your system. How long should you be on the eye treatment? I don't know why you're on that treatment. It is not going to cure MS, and I don't know. I personally wouldn't just take a drug because you've heard that it might be helpful. What happens is when we take a certain treatment, and if we're looking on forums and trying different things, we can take things that we don't need to take. And if you don't take the right amount, you can either hurt yourself if it's too much, or you actually don't treat the parasite and they become resistant, and then you can't use it in the future. It won't work for them. So we wouldn't just recommend any treatment for anyone. You want to be energy tested to see which treatments work for the parasites that you're dealing with. All right, there's lots more questions. Keep them coming in. We will answer them, but I'm going to let you guys go. So if you are new to all of this, make sure to watch my videos on YouTube and Rumble. Again, we're moving more onto Rumble in time, but also Facebook. You'll find some replays there. Our website, you'll find lots of resources there. Learn about the infections, learn about the parasites. Like Jennifer, do a little bit of digging. You're going to see that, oh my gosh, that there's way more than viruses involved here. And if you focus on viruses, you're going to keep the multiple sclerosis, unfortunately. The second thing is, when you're ready, if you believe you have parasites and you want support, you want a proven plan, I can help you in the Live Disease-Free plan. We also have other coaches that can help you. And so we are here for you with whatever information you need. We want you to live your best life. So take care. Bye-bye for now.